Welcome back. This will be the second part of the fifth section of the prerequisites chapter, and again we'll pick up where we left off on factoring trinomials here. So again, when we look at this quadratic, so degree 2 polynomial, we know that we should factor this into something times x plus something. So this binomial times something times x plus something, and we just have to fill in the boxes and the blanks here. And we know that when we multiply the first terms here together, we should just get x squared. Well, the coefficient here is just 1, so when we multiply the things in the boxes, we should just get 1. And ignoring fractions and decimals for the moment, the only way to get 1 will be to multiply x, just 1x and 1x. So furthermore, we'll need to figure out these blanks, and when we multiply both of these together, we should get the constant term at the end. So what are all the ways that we can multiply two integers together to get negative 14? Well, I can multiply negative 1 and 14. I could multiply negative 2 and 7. I could multiply 2 and negative 7, or 1 and negative 14. And if I were to plug these numbers in here, x minus 1 times x plus 14, I know that the x times the x will give me the x squared. I know that the minus 1 and the 14 will give us the minus 14, but this middle term, I'll have 14x minus 1x will give us 13x, which is not correct. So we know that it's not these two coefficients. The same for minus 2 and plus 7. When I just look at this inside term, because I know that the first and the last terms will be correct. If I take x times 7, I'll get 7x. Negative 2 times x, negative 2x. Add those together, I'll get 5x, which is almost right, but it's the wrong sign. So this will be the correct factor, and I'll have x plus 2 times x minus 7. So at the end of the day, this will be the correct combination of binomials. Things get a little bit more complicated when that first term doesn't begin with, doesn't have a 1 as the coefficient. So here, again, we'll approach this in exactly the same way. This will be the product of two binomials. And we know that what we want here is for the product of the first terms to be equal to 6. So in fact, there are a couple different ways I could do this. I could have 2x plus something times 3x plus something, or I could have it as 1 times x plus something times 6 times x plus something. Okay. So these are the different ways that I can multiply together to get 6, but now the product of the constant terms in here, these blanks, will have to be negative 7. So I could put a negative 1 and a plus 7 in here, or I could reverse them, and I could have 2x plus a blank, 3x plus a blank, but I could put the plus 7 in the first one, or the minus 1 in the second. And likewise, I can do the same thing for 1x plus blank and 6x plus blank. Now, here I have a minus 1 and a plus 7. I could do the entire same thing, but switching those signs around. I could have minus 7 and plus 1. So ultimately, we'll have 8 different things that we would need to check. And once we find the correct one, though, we don't have to check check the rest. There will only be one correct answer here. So let me finish writing down the last of the options, and we'll check one, but knowing what the answer is, I will simply describe what it looks like. So let's check our very first one here. So if I write down 2x minus 1 times 3x plus 7, when we look at this, I know that I get 6x squared to begin with, because the 2x and the 3x will multiply together to give me the 3x squared. The two constant terms, minus 1 and plus 7, will give me a minus 7 at the very end. But what about the inner and outer terms? Well, if we do the outer term first, this will be 2x times a 7, that's 14x. And then the inner terms, so that was the outer terms, and then the inner terms, a minus 1 and a 3x. This doesn't add up to what we want. 14x minus 3 was only 11. But we want 19. So you would have to go through and just check each of these. You can use a little bit of intuition to make things come out the right way. We need to add up all the way up to 19. So one way that I came up with this is I tried to multiply the biggest numbers together, the 7 and the 3x, so that when I actually FOIL this out, the first terms, 2x and 3x, the outer terms, 2x minus 1, the inner terms, and this is what I tried to make as big as possible, 7 times 3x is 21x, and then the 7 and the minus 1. And the reason I made it as big as possible is so that they could add up to 19, which is fairly big when you compare it to some of these other numbers. So this is quite a bit of work. It's a little bit of guess and check, but you can use some intuition to try to make things come out. Now, there are some common forms, and these will make factoring a lot nicer. So remember that when we took the product of these two conjugates, we just got a squared minus b squared. So again, a plus b times a minus b. The outer and inner terms cancel, so you're left with something that looks like this. This will make things a lot simpler. So for instance here, I've got x squared minus 25. That's the same thing as x squared minus 5 squared. And using our formula, this is going to be the same thing as x plus 5 times x minus 5. Again, if we were to FOIL this out, we'd have the x squared term as the first term, we'd have 5 times negative 5 to be the last term, and the inner and outer terms are going to be minus 5 and plus 5, which cancel. And again, we can do the same thing here. We'll notice that this first term, 4 times x squared, is the same thing as 2x, quantity squared. And we're subtracting 81, which is 9 squared. So this is going to be the same thing as 2x plus 9 times 2x minus 9. Now, one thing that I haven't really come across yet is what we'll see in this next example. This is fairly straightforward. Again, we've got something squared minus something squared. In particular, it's x squared minus 4 squared. So I can factor this into x squared plus 4 and x squared minus 4. And here, what you'll notice is that this second factor is again a difference of squares. It's x squared minus 2 squared. So I can factor this second term out even more. I've got x squared plus 4. This second one, if I write it down explicitly, this is going to be x squared minus 2 squared. So this first term will just stick around. This second term is going to become x plus 2 times x minus 2. And then you could ask, well, have we factored all of these? Here we don't have an x squared anymore, and there's nothing that we can pull out of both the x and the -2. Same thing here. There's no x squared. Everything's done. This last term is maybe the least obvious, but here we can't factor something squared plus something else. Both these terms are positive, so it means that we won't be able to factor this one without having just an x term by itself. And we'll do lots of examples of these, and you'll be very, very good at these at the end of the semester. The last things that we'll do is remembering what happens if you square a binomial sum and a binomial difference. We end up having the a squared and the b squared, but the inner and outer terms of a plus b are just a times b, and there are two of them. So these forms are very nice. So sometimes it'll be easy to recognize that what we have is going to be an a plus b squared or an a minus b squared. So again, when we look at this, our first example, x squared plus 14x plus 49, what we'll recognize is this is going to be x squared. This last term is going to be 7 squared, and the middle term is 2 times 7 times x. And this fits our formula. We've got a squared term, another squared term, and a 2 times both of them. So this is going to be x plus 7, quantity squared. Again, we can do this with the next one. If we stare at this long enough, we'll be able to recognize that this first term is going to be 4 times x squared. This last one is going to be 5 squared, and the middle term is we're going to subtract 2 times 5 times 4x. Again, the 4x and the 5. So when we can factor this, you can see that this will be 4x minus 5 quantity squared, and this is just coming from remembering these formulas. And we'll finish off the section in the next video.